Okay, good afternoon, everyone. Welcome to APNIC eLearning web class. Now we'll be doing reverse DNS delegation. So, in our presentation today, what we'll be covering is what is reverse DNS delegation and how you delegate your reverse DNS domain towards your name server from APNIC, right? So that's what we'll be discussing today. So before I move on, a little bit about introduction about the presenter. My name is Nurul Islam Roman. I'm the senior training specialist now in APNIC. I'm in APNIC since 2006. So if you can see on the presentation slide, I have got interest on a few topics. So if you have any question, you can ask your question anytime when I'll be presenting. So to ask your question, just need to type your question on the chat box, and then I'll try to answer your question as quickly as I can. All right. So this is what an overview for today. We'll try to define what is reverse DNS delegation, why we need it for, what are the principles for reverse DNS tree. So we'd like to sort of clarify the concept of reverse DNS tree, right, from the root all the way up to the child, how the tree has been formed, and how you deal with the tree when you need to. Then we'll show you how to create a reverse zone in your DNS server, and what are PTR record, right, and how you can prepare your DNS server with all those necessary attributes. Then towards the end, we will show you what is reverse delegation, and then how you can make reverse DNS delegation in APNIC DNS servers through Whois database object, for example, domain object. Okay, I'll try to clarify those understanding. What is the relationship between domain object and doing the reverse DNS delegation? Sense? So, what is reverse DNS? We know very well about DNS. DNS stands for domain name service, which is in internet when you need to browse any things or send email to someone, right, or if you want to download something from some FTP site, what you do, you create a connection with the machine on the other side, or for example to the destination side, by just typing the name of the machine, right? So for example, www.apnic.net. If you type this name www.apnic.net on your browser, then what your browser will do, your browser behind the scene, they'll convert the name into IP address, because in internet all the communication from the source to the destination, all the routing are done based on IP address. But what you did on your browser is you specified the name of the machine, right? So in the computer, you should have a system in place to convert the name into an IP address. When your name will be converted into an IP address, right, then your machine, or the name you have typed has been converted into an IP address, then your machine can create a connection with the destination machine. Then when the connection will be established, then data can come. Right, so that's what the purpose of DNS, but that is forward DNS, converting name to IP, right? But in internet, for some application, for some functionality, we need to convert other way around, from IP to name. Right, from IP to name we also need to convert. Why is that? Why we need that? So for example, for the secure functionality of the internet, we need the conversion in both way, from name to IP and IP to name. Probably if you use email or some other applications, for example FTP, you'll see even some troubleshooting application, for example trace routes and all, they convert the IP to name, right? Say if you send any email, if the source machine who is sending the email doesn't have the proper reverse DNS delegation, then what will happen in internet when you send that email to the mail server, the receiving email server sometimes can reject any email from you because you don't have the reverse DNS mapping. That is what most visible case. But in the troubleshooting, say in trace route, right, you'll probably noticed without the PTR record, sometimes it doesn't work the way you expect. Okay, so let's see what are the significance of that. As I said, without reverse DNS delegation, some of the service denial you can experience. So for example, as I said, from the source machine, when you send any email doesn't have the PTR record, the receiving email server will not accept any email. That's what we call service denial. Some anonymous FTP, right, without the PTR record doesn't work. Diagnosis, as I said, trace out. So for those functionalities to work properly, you must have reverse DNS delegation done properly. Let's have a look. What is the tree structure first? So for example, when you browse internet from your machine has already configured with a local DNS server IP address, right? That is either by DHCP server or statically configured with the local DNS server. So when you browse www.apnic.net, then there is a client application on your machine, on the operating system, a part of the OS. That client application, we call it resolver. They talk to the local DNS server, right? So when they goes to the local DNS server and ask the local DNS server, what is the IP address of www.apnic.net? Okay, so if your local DNS server is not authorized for the domain apnic.net, then what it will do, it will check in his cache, right? And in the cache also the record is not there, right? So what then it will do, it will create a session to the root server. How it knows the IP address of the root server? Because that IP address is already in the namely.hin file, right? So based on that, it create a session with the root server and asks the root server who is the delegated name server for .NET, right? So the root will point towards the .NET name server. So how root will be able to tell .NET name server's IP address? Because this is how the delegation has been done on the root, right? When some operators become .NET domain operators, some internet operators, right? Then the delegation has been done at that time. So net or for .NET domain, who is the delegated name server, root has been already updated. That's what we call delegation, right? This is how your local DNS server will get the IP address of .NET delegated name servers. Then it will create a session with the .NET delegated name server, and on the .NET delegated name server it will ask who is authorized for the domain APNIC, right? Yeah, so this is how then your name server knows the delegated name server of APNIC. Then it creates another session with APNIC name server, and from the APNIC name server it asks what is the IP address of www, and APNIC name server has got the record in place, right? So this is how APNIC name server will delegate the IP address of www.apnic.net. So if you see on the whole tree, that is done on forward domain. Now we will see the reverse domain. Under the global top level domain, like here in this level, the global top level domain, apart from those popular top level domain, there is an infrastructure top level domain which is ARPA there, right? There is an infrastructure top level domain which is ARPA there. What is the purpose of ARPA? Well, if you see in internet, when the IP address has been distributed, right, some of the IP address probably are not being used at that time. Some of the IP address probably been used. So for those unused IP address, sometimes the spammers who send spam email, right, they send an email with the source address of all those unutilized IP address as a source of your message, email message. So when the message comes to the receiving mail server, if they accept that email without any verification, then afterward, if they need to find out who sent that email, right, they cannot identify because the source of the email is already spoofed with someone else's IP address. So we can't find out the real person. Or if the source has been used as unutilized IP address, then it's a problem. If the source is unutilized IP address, then it's a problem, because when you need to find out, figure out, or to verify the identity afterward, then you can't find, because unutilized address, whom should you go and catch, right? So that is why this validity checking should be done at the first place before the email will be accepted by the receiving MTA or mail server. So how the receiving mail server will validate that before it accepts the email? What it does, the IP address that it is claiming, the sending MTA or mail server, or the sort of not mail server, so for example, sending person, so who is identified as the source of the email, right? Before the receiving email server will accept that email, what it will do, it will check that source IP address. Then from the IP address that it received on the source header of the email, it go and ask the root, okay, root, can you see whether from the root all the way up to the service provider who is claiming the IP address, the delegations are properly done or not, right? So in that case, when, say for example, any receiving MTA or mailing server will receive an email with a source, say for example 202.64.22.10, right? So for example, the source of the email is 202.64.22.10, right? So what he will do, or receiving email server will do, he will ask, okay, for that IP address, what will be the equivalent ARPA domain? ARPA domain will be 22.64.20.in-addr.arpa. It will go and ask the root, okay, what is the IP address of ARPA, delegated name server? Then in ARPA, what is the IP address of in-addr delegated name servers? Then from there, first level of the domain is 2002, right? And then from there 64, then 22. This is how it goes and check all the way up to the domain, ARPA domain where it is hosted. And if all the PTI records are properly done, then the source, then the receiving MTA will consider this IP address is a valid one, because someone has properly maintained the PTI record. But if the IP address is not utilized, bogon IP address, then what happened? When those PTI record will be checked, then somewhere at that delegation line, it will be broken, right? Because ARPA or all the registries, they will not create any delegation to those spoofed IP address, right? Or unutilized IP address. So when the delegations are not there, even those the hackers, they maintain their PTI record, it will not work. So this is how this is how the reverse DNS will be, or reverse DNS tree will be checked, right? And this is how the receiving MTA will determine whether the IP address has been utilized or not, right? So if you see the reverse DNS tree in IPv4, how it is work? Let me see whether we have a slide for that. Okay, we have the slide for IPv6 anyway. So how the reverse DNS delegation tree works? Normally in IPv4, all the delegations are work on class full boundary. So for example, class A, class B, and class C, right? And 3 level. So if you receive any IP address, so for example, 202.64.22.0/24 IP address, right? Then if you see on that ARPA tree under in-addr, at the first level of that tree, that start from 0 all the way up to 255, right? So that is what the class A of the tree, the first level, from 0 all the way up to 255. Then at the second level, on each branch of the tree, for example 0 or 1 or 2 or 3 up to 255 on the first level, on each branch there will be another expansion of 0 up to 255. That is what second octet of IPv4 address, because second octet of IPv4 address, that will be ranging from 0 all the way up to 255, right? So this is what probably the second level of it. Then on the third level, again on each branch of the tree there will be a tree from 0 up to 255, right? So this is how all the branches of the tree will be expanded. Now if you receive a block which is 202.64.22/24, then on that long branch you have to make a delegation, right, on that level, like 22. So for example, here what happened, when a block will be received by APNIC from IANA, so for example 202 block APNIC has received, which is /8, then under in-addr IANA they will make a delegations for the 202 block towards APNIC name server, which is ns1.apnic.net, ns2.apnic.net, so for example, so that the whole 202 block, the delegated name server will be ns1.apnic.net, ns2.apnic.net, for example, right? So from that 202 block, when APNIC will make any delegations towards their members, say for example in your case you receive 202.64.22, then what APNIC will do, all the way up to, so for example 202.64/16 you receive, right? Then what APNIC will do, from that smaller branch 202, they have got another smaller branch from 0 all the way up to 255. From that expansion, only block 64 will be delegated to us to your name server if you receive a /16. But if you receive a /24, then on the third level the delegation will be done. And as you can see on the DNS tree or reverse DNS tree, delegations are possible for IPv4 only on class full boundary, either on /8, /16 or /24, right? Now the question is, okay, being a member of APNIC, if any organization receive a /17, then how they will make the delegation? Well, if they receive a /17, it means how many /16 they have got? Probably not, no 16, right? But then on the /16 level, it will not be possible to make delegation because /17 is smaller than 16, right? In terms of the available address range anyway. So then what will be happening? APNIC need to make delegation on the /22 level, /24 level, right? On /24 level, from /17 up to /24, how many bits you have? 7 bit, right? 7 bit means how many /24 are there? there are around 128 number of /24. So APNIC need to make a delegation of 128 number of /24 delegation for you, right? But if you receive a /15, then these things are easier. How it is easier? APNIC can make a delegation for 2/16 for you, because /15 means 2/16, right? So 2/16 delegation would be good enough for you. So this is how the reverse DNS delegation tree works. Is there any question by any chance from the participants? Is it all clear about the level and trees? No question? Okay. So if you see the delegation function, how it works for IPv6, right? So in IPv6, the same way under ARPA, there is a branch called IP6 that is under ARPA. So for IPv6, the branch didn't sort of connected to in-ADDR, but for IPv6, the branch actually connected directly to ARPA.IP6. Initially, like for internet, they started with INT, but that has been deprecated by RFC 3152. So now IPv6 actually went under ARPA to create infrastructure level DNS tree for IPv6. So then under IPv6, DNS delegation works on every hex digit. DNS delegation works on every hex digit. So for example, in IPv6 there are 32 number of hex digit, right? And APNIC being a registry, they allocate by default /32 to service provider. When they allocate /32 for service provider, then the service provider will receive 8 hex digit from APNIC, /32, 8 hex digit. So APNIC will make a delegation towards 8 number of hex digit, and from there, if you create further subnet, right, you'll get another 8 hex digit to be delegated towards your subnets. Okay, so that is how reverse DNS delegation tree works for IPv6. So one thing need to remember, for IPv4, reverse DNS delegation boundary will be on each octet, like /8, /16 or /22. But for IPv6, this is on every hex digit. That's what we call nibble digit. Every hex digit, there will be a possibility of making delegation. Okay. How you'll create reverse zone? How can you create reverse zone? Creating reverse zone is not very different than creating forward zone. Same as forward zone. You need SOA, start of authority, and initial NS records, same as normal zone. But the main difference between the zone file of forward DNS and reverse DNS is, in the reverse DNS, all the record type that you add is PTR record or pointer record. Okay, but probably you don't create those PTR record on your forward zone file. You can use the same software like Bind to create your reverse DNS domain. Bind is open source and widely used DNS software, right? So you can use the same Bind software to create your reverse DNS zone. Okay. To create a reverse zone, what are the file that you need? You need a zone file, right? Your db.domains, for example, db.apnic.net in APNIC case, and then you need a zone file for reverse as well. For example, APNIC IP address that APNIC used in the network is 254.168.192.0/24. Then the equivalent reverse zone file normally people use this naming convention, which is db.192.168.254, right, based on your ARPA domain from that IP address. Then you need to edit the config file, which is namely.conf file, and named.conf file is a config file. You do all the DNS related configuration on this file named.conf, right? And then you create the zone file in the respective directory that I can explain later on. Then you have your hin file, which is sometimes root.hin, db.cache, name.cache, or name.ca. So this file you should get the latest one, updated one from ISC website. If you're using bind, isc.org. This hin file contain all 13 root DNS operators and their IP addresses, right? And if any root servers, root DNS operators, they add IPv6 file, because nowadays they're migrating towards IPv6, those can be reflected into their hins file that you can download from ISC website, the latest one. Now we'll see the startup authority or SOA record. In the SOA record, how we start? We start with the domain name and then a class, which class it is, right? And then startup authority and then host name and domain name. This is how we write the FQDN name of the DNS service. It has to be the FQDN name. Then the email address of the DNS operators or the DNS administrator. The email address we write in a differently, not with the red symbol. We use with the dot mailbox.domain.name. So what is your domain name? Then we specify all the zone related configuration, like control configuration. Those attributes that you can see in here that related to the secondary. What is the secondary server? So for example, in DNS, to be able to ensure the redundancy, we might have secondary DNS, and we normally place secondary DNS outside of our network for the redundancy purpose. So for example, if your DNS is authorized for any domain, forward or reverse, right, to be able to ensure the full redundancy of your network, we should not place our secondary on the same network, because if the network is down, then both primary and secondary are unreachable. So secondary is supposed to be outside of my network, right? So if my current or the main network is down, still the secondary can be able to provide the information to the others who are querying, right? So because of the secondary and primary issues, all those secondary and primary, how we refresh zone record, we use those parameters or attributes here. What are those attributes used for? Say for example, my primary, I have a primary and I have a secondary. So all the domain related record, either reverse or forward, if I change on the primary, right, and if I change the serial number, because every time I change the zone file in the primary, and if I change the serial number in here, right, then what happened? From the secondary, they will check or keep changing. There is a mechanism to check the serial number. If the secondary found the primary has changed the serial number, it means definitely primary has updated their DB record. Then they initiate a zone transfer with the primary, right? So by doing the zone transfer, primary become secondary become updated with all the changes that primary does, right? Then the refresh time, like how often they will refresh it, the primary and secondary. How often they try, if the first attempt has been failed, then up to which time the secondary will keep the record active or valid if they cannot communicate with the primary for some reason, right? And minimum TTL time, how long it will be valid in the cache. So that will be or that can be manipulated. Okay. Okay. The TTL values, normally the values that we use on there, if you don't do anything, don't do any change, then the DNS will take the default value. So the default values are something similar to that based on the RFC. You need to change those values depending on your situation, your scenarios. So for example, in your network, if you or if your sort of domain handling is so frequent. So for example, if you are a domain hosting company, right, you keep change your DNS record every sort of 10 minutes, 5 minutes, based on the frequency of your customer interaction, then you need to adjust those parameters. But if you think your DNS server you don't change, like, you know, every day, probably once a week, then probably you can rely on the default time. Okay. Pointer record or PTR record. So you create a pointer record or PTR record in this way. So for example, on your zone file, what do? You type the whole IP address, right, of the machine. So for example, the machine has got IP address of 202.12.28.131, right? So you create an ARPA domain for that machine, which is 131.28.12.202 in-addr.arpa, right? And then internet pointer record and then the host name of the machine. Or if you create an SO record on top of the file, then you just use the host IP address, because remaining 3 octet plus the remaining ARPA domain will be collected from SO record, then in PTR and the host name of the machine. So in 2 ways you can write the PTR record on the zone file. Is that clear? Is there any question about that? If not, then you can move on. Similarly, if you see how we can create PTR record for IPv6, right? So in IPv6, as I said, the PTR record interval will be each hex digit, right? So if your machine is using an IP address which is 4321, if you see that start from the other side, if you're looking at the slide carefully, this is where the starting, the IP address is 4321 colon 0000 colon 0001 colon 0002 colon 0003 colon 0004 colon 0067 colon 89 AB, right? So how many hex digits we have? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32, right? So we have 32 hex digit in IPv6, which is 32 times 4 equal to 128 bit. So if you see the PTR record that you can create each hex digit and then in a reverse way, then in PTR test ipv6.example.com, right? This is how you can create. Or you can use origin directives, like origin and then your domain, not domain, sorry, your subnets, right? And then it will create the remaining part like this, and they keep changing one by one. Since IPv6 is too big, right, we should use some tools to do that. So if you see the complexity in V4 and V6 almost similar, right? Almost similar. We just need to know the interval, like which interval IPv4 works, which is octets /A, class A, class B, and class C. And in IPv6, it works on hex digit, right? Every hex digit we can create the delegation, and this is how we can create the ARPA domain as well in IPv6, right? So one of the example of reverse zone file, as I said, so that is what your SO record and origin directives. This is what your domain, right, in origin, and then your SO record and all the secondary parameters and your name servers, and then the PTR record in IPv4. So since in here as an example 1, so it will go to the origin directive. So 1.168.192, sorry, 1.1.168.192, right? And then 2 PTRNS company.org will be 2.1.168.192 in -addr.arpa, right? And then if we have DSL service, right, And normally in DSL service we add FQDN name on each DSL port. So like 16 port or 2000 port DSL or DSLAM. So you just use the origin directives and create all required PTR record for all those DSL ports where your host will be connecting. Okay, as I said, reverse DNS delegation requirement that works on class full boundaries /24. Normally, if you receive a /24 delegation from APNIC, then definitely you need to create your DNS with the PTR record. How will you do that? If you see all the steps, first things what you need to do, you need to configure the named.conf file, add that zone statement for your ARPA domain, right? And then you specify your zone file path. It's already in the named.conf file, global directives or global areas. From there, you go to the zone file path and create the zone file, right? In the zone file, you specify all those PTR record. Then the configuration is loaded onto your DNS by restarting, the DNS service or server service. Then what you do, if the zones are all loaded, then you come to APNIC and ask APNIC to create the delegation for you, right? Now the question is, when we ask APNIC to create the delegation, under what boundary APNIC will add the delegation? If you receive only 1/24, then definitely APNIC will get only one delegation for you, right? But if you receive 2/24, right, which is /23, then in APNIC area you need to create 2 delegation for 2/24. If you receive 4/24, which is /22, then you need to create 4 delegation. If you receive 8/24, which is /21, then you need to create 8 individual delegation, right? So this is how up to /617 if you receive, then you have to create 128 number of delegation, right? Because on that range the available delegation range is /24. But if you receive a /16, then you belongs to the next delegation range, which is /16. So for /16 block you can get only 1 delegation. Okay. This is also possible to create delegation which is less than /24, but that is only for the client side. On the ISP side, APNIC will not do that, and for that you can use an RFC 2317 that explain how to create delegation which is less than /24. Okay, when you do the delegation, what is the responsibility of APNIC and what is the responsibility of ISPs? Normally APNIC they manage reverse delegation for the IP block APNIC has given. So what APNIC does, APNIC only manages the delegation part of it, right? Delegation means from the root all the way up to when it comes to APNIC, APNIC will point it to us to your name server. But the actual PTR record, the organization need to manage by themselves, right? Organization, they need to manage the PTR record by themselves. In APNIC, they can ask only to make the delegation, and APNIC will do that. Now the question is how APNIC will make the delegation. Is there any automated process or is it a manual process? Well, it's an automated process. For the reverse DNS delegation, you need to create a domain object into the APNIC Whois database, right? So how you will create the domain object? To create the domain object, if those domain object already there is protected by a maintainer that you know the password, you can update that, right? Or if you don't know the password, you send an email to helpdesk@apnic.net, right? They can add the delegation for you. Or you can use MyAPNIC, which is the latest one and which is the most scalable one and secure one. So through MyAPNIC, you can make your delegation, and it is very quick. So this is what an interface of MyAPNIC. By using this interface, you can add the delegation. So when an IP block will be given to you, right, and then you'll have an username and password to log into MyAPNIC. When you log into MyAPNIC, then you can go to the resource section of MyAPNIC like this. Under resource, you go your IPv4, and then you will see the add reverse DNS delegation. So when you go to this page, reverse DNS delegation, you specify your address range, then you specify your name server, right, and then you specify the maintainer. And the name server that you are specifying, as I said, those name server has to be configured already with the zone loaded. Otherwise, if you don't configure the zone file or the DNS, but you are coming here to make the delegation, the system will give you an error message, because before adding the delegation, the system will check with the DNS server whether those syntax are correct or whether the name server has been configured, right? So when the domain object has been created, then we have a script at the back between the Whois database and our APNIC DNS server. That script will automatically copy those delegated name server and add a zone record into APNIC Whois server. That's it. Okay, so that is what a domain object look like. So in the domain object, what you do is specify the ARPA domain. If you are not using MyAPNIC, if you are using sort of email updates or probably asking the hostmaster to do that, then you specify admin C text here, some description. Then this part is important. You specify the name servers. Who are the name servers? So the name servers that you have specified here will be added into APNIC DNS server. Okay. That's it. That's the end of the presentation for today. Is there any question from the participants about reverse DNS? Okay, if you don't have any question at this stage, what I would request you, I would suggest you to sort of give us some feedback, because your feedback for the presentation will be useful for us to improve our future e-learning session. I'll just type that URL for you, webmonkey.com/s/ So this is what the URL that you can use to send us the feedback. So after you, oh sorry, I put the wrong URL. Just correct it for you. APNIC.com/s/ap. Yep, that's the correct one. Okay, so hope the session will be useful, and if you have any question, you can send your question to training team at training@apnic.net, or you can send email to our help desk to interact our help desk. This is what the help desk page. You can contact help desk by sending email at helpdesk@apnic.net, or you can come to online chat. So APNIC help desk runs an online chat, so you can use that to come to APNIC help desk. All right, so I hope the session is useful, and we'll see you in our future e-learning.